My name's Christy Lynch and the company's Efficient Renewables. Myself and Jonathan Doherty as directors of the company. We've two core products within our company. One of them is the EcoForest heat pump and the other is the thermodynamic solar panel. The EcoForest heat pump is fairly new in the Irish climate, so it is. We've about 5 of the heat pumps fitted now at the moment, but there's over 800 of them fitted throughout Europe. They're very popular in England. The heat pump itself comes in 3 different types. You have a ground source heat pump, a deep borehole, or air source. But really it comes down to the design of the house, the person's lifestyle, and the building regulations of a house. A whole lot of houses now with the new Part L only comply with certain products, and to meet them we've different designs to suit that, so we do. This here's the air source heat pump. This is actually fitted in my own house. At Christmas time there we had a bit of snow and temperatures dropped around my area to -7. But I didn't notice no difference in my house because the heat pump has weather compensation, and the heat pump will modulate up and down to suit the requirements of the house. So if there's only 1 or 2 bathrooms calling for heat in the house, the heat pump will slow right down. The size that I've in my own house and a lot of houses is from a 5 to a 22 kilowatt. So if you only have 1 or 2 bathrooms calling for heat, the heat pump will just slow right down and go very slow. Where if you have all the house calling for heat, it'll ramp up and give more heat to the house. It's like an automatic version of the car. It'll only give what's required at the time. And this both saves on electricity and saves the labour of the heat pump as well, so it prolongs the lifespan of the machine. This here's a flat loop collector. The one on the left is for a house in Castlefin we installed, where we installed the grid of pipework out in the garden. This heat pump is a 3 to 12 kilowatt heat pump. This will reduce all the heat and the hot water for the house, so it will. And in this size of a house, in that particular house there, the house is about 250 square metres, and we can guarantee the running cost in that house. So we'll give a signed document guaranteeing the running cost to be, in this particular case, €750 for the year. That's for all the heat and hot water, and that's heat and hot water 24/7. This case is a borehole where maybe the area wasn't round, they didn't have the area of the garden. Maybe it's in a town or within a town that they don't have big gardens of that, where we drill the hole in the ground. The deeper you get into the ground, the more consistent the temperature is. So we would, for a standard house of about 2,000 square foot, you'd be going 150 metres deep. But the cost of drilling sometimes is expensive, and it might be more beneficial going with an air source heat pump. The heat pumps that we have a sensor in every single room in the house, and that sensor is directly connected with the heat pump. So there's only, as I was saying earlier, if there's only 1 bathroom calling for heat, the sensor has the ability to bring on the heat pump and heat that 1 room. And it can be controlled from anywhere in the world as well. You can log into your mobile phone or your laptop and see exactly what temperature it is in the house from anywhere. The heat pump has the highest COP in Europe at the moment. That means for every euro of electricity you put in, you get 4.9 back. And that's measured at 0 degrees outside and given a room temperature of 21 or 22 degrees. The fan collector outside, which I showed you where there's snow on it, the fan collector is the most efficient fan collector that's there. It's really silent. If you're standing beside it, you would hear it, but if you're a couple of metres from away, you could barely hear it. This particular house here in Dunfanaghy, this house is roughly about 3,300 square foot. There's high ceilings in the house. This particular end of the house here is open right to the peak. There's 4 en-suites and 2 main bathrooms in the house. This house will cost about €800 a year to run for all the heat and hot water, so it will. The cost of install for this, we done the heating and the plumbing in this house, the cost of install was €26,000. So a payback period though of maybe about 5 years, so it will. And that's comfort heat all the time. These 2 people that own this house, is in the house probably 70%, they work from home 70% of the time. Every house that we do, as this is, we give a running cost. So as I was saying, that particular house there, year 6, the payback period, that house would have cost about 3.5 grand in oil per year for the same. It would cost about 3.5 grand for the same level of heat in the house. So what? This here's the cost monitor that's on the heat pump. So this here shows the electric power consumption. That shows it's using 1.4 kilowatt. So that means the heat pump has slowed right down. There's only a couple of rooms calling for heat, so it's slowed right down. It's only using 1.4 kilowatts of heat, and it's producing just over 7 kilowatts of heat. This is giving us a COP of 5. That means every euro you put in, you're getting 5 euros of heat back out of that heat pump. If you had an oil boiler, every euro that you put in, you're only getting about 90 cents back out. This here is the lab in Vigo in Spain, where we would visit every year for training. Inside here, the machines put in the test it, and in that there it's minus 19, and the machine's still producing heat. The way if those of you who's building new houses and putting in on the floor heating, it's very important the way your insulation's laid on the floor as well as throughout the house. What we would try and get clients of ours to do is, if you're putting in 100 mil or 120 mil insulation, put it in 2 layers, crisscross the insulation and tape the joints. And then around the walls then you should use either a 30 mil strip of insulation around the walls. A lot of people would tend to use the 10 mil strip of expansion joint. But that wall is a thermal mass, and it sucks heat in, and it'll suck the heat down to the subfloor. If you think about it, if your subfloor is poured, there's nothing stopping your subfloor's poured, your blocks are laid, there's nothing there to take apart the block to the subfloor. There's no insulation there. The block goes directly on top of the subfloor. So the heat's sucked by the block down into the subfloor, and you're losing heat there. If you put a thermal imaging camera in that, you'd see that happening. What we would tell people to do is put a 30 or 50 mil strip around the whole room, so the whole room's sealed in. So it is. And then what we would tell people to do then is to lay a plastic all over the floor, like this, the blue plastic here, a heavy gauge plastic, so the whole floor is a sealed floor then. And by doing this, you're doing 2 things. You keep the moisture in the screed, so the drying out time is prolonged, which is very important. And then what has happened in the past, the screed will actually eat the silverback on the kingspan and the extra therm insulation, and this will prevent this from happening. This here's a job we're doing not far from here, and we put in a grip rail system where we click the pipes into the grip rail through the floor, so that the pipes up over the floor, so the screed comes fully unbound in the pipe. This here just shows it's ready for screed. We use manifold cabinets. If requested, we give an option for them. It just keeps the whole thing tidy, and any electrics or anything like that, it's kept behind it, just like so. Has anybody any questions on that? It's a fairly brief overview of it, but if you want to come out there or stand afterwards, but don't be afraid to ask any questions as you have. We do. Yep.
See the house you compared capacity under to heat? Was that down in drill? Or one side the heat, one was that?
That particular house there was a borehole, but it can be either or. The difference between going with a borehole and air thermal is about 10%. It'll cost about 10% more to run per year if you use a fan collector. If you use air source, but if you use a borehole in the flat loop collector will be a wee bit more efficient. So it would, because of the temperatures we get in Ireland, the minus temperatures we get in Ireland, the air source unit will be struggling a wee bit to run. So it would, compared to the borehole. There's 2 or 3 different types of solar panels in Ireland. You have the solar tubes, and you have the flat plate panels, and you've got thermodynamic solar panels. 90% of the panels we fit as thermodynamic solar panels, which will produce hot water 12 months of the year in all weather conditions. So no matter what the weather is outside, you have hot water all the time. We have the demo unit working there today, producing hot water. On the left-hand side here, you have the panel, and then you have the tank, and this here's a hot press. On the right-hand side here, where you have the tank and the hot press, you have 2 small pipes that goes to the roof, to the panel, and then you have a small little compressor on the front of the tank. That compressor will produce enough of hot water for 6 or 7 showers per day. And this here will work down as far as -15. It'll work in all weather conditions. This house here on the left hand side, we installed a solar panel in it must be about 4 years ago now. This person actually halved their oil bill because there was 3 kids in the house heavily involved in football, and they were sharing maybe twice a day sometimes, and they were using an oil cooker to heat the hot water. So we disconnected the oil cooker from the heating the hot water, and what we done was we left the cooker that'll heat the radiators only. And from that point forward, these people saved money right away. About a 4-year payback period for these people. And from that, there was 3 other family members that actually fitted the solar panels. The benefits of our system, the thermodynamic solar panel, one panel will do up to 6 people in a house, guaranteed 100% hot water all year round. It works in all weather conditions. As the standalone system requires no backup, whereas if you fit solar tubes or flat panels, it'll do about 60% of the hot water, and you have to have an immersion or oil for the winter time to back it up. There's no yearly servicing required. There's no antifreeze within the system. The panel only weighs about 8 kilograms. And if you were to throw a football at the panel or anything like that, it will not damage it. That's really it.